Okay. Hi, everyone. I think we'll get started. So let's see the PowerPoint slide here. Let me share that with you. Okay. All right. So today we'll be checking section 16.4 on the absolute motion analysis. So the objective will be to determine the velocity and acceleration of a rigid body when it's undergoing general plane motion, okay, with using the method called absolute motion analysis. So we'll be looking at, again, we'll do a reading quiz and then check on some applications and then looking at a couple of concept quizzes, attention quiz, and also I think that's one example or two here. So again, we will get started with the reading quiz. Okay, so go ahead and then do the reading quiz. Send me your answers via chat privately. Okay. All right, so it looks like most of you guys have some of your answers. Um, so I just want to emphasize that. So whenever we do a reading quiz at the beginning of lecture, you actually get extra credit. Okay, so each time if you get everything right, you get 0.25% in towards your final grade. Okay, so the reason I'm saying this is because looking at the way you guys submitted, it tells me that not everyone actually did the reading assignment. Because for these two, it's quite straightforward. Okay, if you were reading the, let me see, if you are reading just this section here, it's the first two sentences over here. Okay, so it wouldn't take too long. I think most of the time it takes about 5 minutes. So I would encourage you guys actually spend 5 to 10 minutes each time before the class. Okay, so for this, it will be easy for you guys to get the extra credit. And I do have seen some of you guys already got grades up by earning the extra credits. Okay, so this is very easy to do, and it will help you understanding the content better. Okay, so anyway, it's about the first two sentences here under this section. So the first sentence says the body subject to general plane motion undergoes a simultaneous translation and rotation. Okay, so that's first problem here. So then obviously this one, the answer will be C. Okay. And then the second one, it's the second sentence here. It says if the body is represented by a thin slab, the slab translates in the plane of the slab and rotates about an axis perpendicular to this plane. Okay. So then second quiz here will be the answer will be A. Okay. So it's very easy to earn this extra credit if you have done the reading assignment. Okay. So anyway, so that's the answers. Those are the answers to 1 and 2. All right. Let's get started on the lecture part here. So the application. So a lot of times you see the object will have the translational motion and rotational motion at the same time. For example, for the dumping bin here, the big bin here, it rotates with this point over here, but before that, it's probably been moved by this hydraulic cylinder B and C. Okay, so then it's been pushed over that way. All right. So in this section, it talks about the method called absolute motion analysis. So that's what we are going to see here. This is one of the application here. And then, for example, for the window like this, point B will be moved by this, again, the hydraulic um, rod here, A and B, and then this guy is relative also, this distance S is relative or it's related to the angle here, okay? So we are going to check how you actually can solve a problem like this here in this section. So the method, it's called the absolute motion analysis. So it actually relates the position of particular point B, in this case here. So if we still look at the example of the windows here, so the absolute position of point B with respect to a fixed point, okay? So this is S, and you can relate. So it also, so this, for this point over here, also undergoing the motion that is relative to the angle here, theta. Okay, so then we can actually define S and theta there. So you can write the relationship between the S and then the theta. Okay, so S would be a function of the theta, and then if starting from there, you are going to do time derivative, or the first time derivative of this equation, then you are going to relate the velocity with the angular velocity. Okay, so the linear velocity can be related to the angular velocity by doing the first time derivative. And then if you do second time derivative, then you can relate the oscillation, linear oscillation to the angular oscillation of this point B here, okay? Now, keep in mind that when you are doing time derivative, so here, if you are doing first time derivative or second time derivative to this relationship, because then the variable here is theta, it's not time variable, okay? So then you will have to apply chain rule, meaning like you will have to do derivative of this function with respect to theta, and then multiply by the theta, derivative of theta with respect to time t, okay? So here are the procedures on how to use this method. So the first, you want to locate a point on the body using the position coordinate s, okay? And that's referred to a fixed origin or fixed point, okay? So you are measuring this from a fixed origin. And then second, you are going to find a fixed reference line where you can set up the angular position theta, the variable angular position theta with respect to that reference point, okay? So then you can relate the position coordinate to the angular position. So for example, you write s in a function of theta, okay? Then you're going to take time derivative, first time derivative to get relationship between the linear velocity v and then the angular velocity omega, okay? And then take the second time derivative, you'll get relationship between the linear oscillation a and then the angular oscillation alpha, okay? So so let's take a look, or let's actually do some exercise here. So again, I'm going to set up couple breakout rooms so you guys can actually have discussion and then work on these two problems. Okay, so let me set up the breakout rooms for you. I'm going to again set 4 breakout rooms. So some of you guys will have 2 in the room, and then some of you guys will have 3 of you in the room. Okay, and then as you are done with your discussion, send me your answers. Then you can leave the breakout room. You can come back to the main room. Okay. So in case when you come to the main room, you don't see me, that means I'm probably in one of the breakout rooms. So just wait a few, like 1 or 2 minutes, then I'll be back. Okay. So let's do that. All right, so let me open the room so you guys can join the room.
Dr. Ho.
Oh, is he back?
Yeah.
Hey
Okay, so I
guys,
can send it to him now.
are you
Hey,
done?
Dr. Ho. Yes.
Okay,
Send
so
We
let's
to
go
found that
back to
the
the main
first
room.
one was C.
Yes, you are right.
C.
Yay!
How
And
about
then
that?
the second one, it should be B, right?
Correct. Awesome.
Excellent. Sweet.
All right, so let's get back to the main room.
All
All
right.
right. Sweet.
Okay. All right, it looks like you guys are doing very good on the concept quizzes. So let's just wait a couple of minutes before Obi and Parker join us back, okay? All right, so now everyone is back. So let's take a look. So I received responses from you guys. You all got C and B. So those are the correct answers. Okay, but let me just quickly went through this one. So the first one says S is equal to 10 times sine of 2 theta. Okay, so then in order to figure out the velocity, you'll be doing time derivative to this guy. So that means v, if you do time derivative, gives you v, okay? ds over dt gives you v. That should equal to doing time derivative of this one. So 10 again goes down here. Now you have sine, it becomes cosine of 2 theta, okay? Now, after that, so this is the variable over here. You apply chain rule here. So you want to take a derivative of this, okay? 2 times theta, so it becomes 2 theta dot, okay? So at the end, this is what you have. You have 2 here, so 20, and then theta dot will be omega, okay? So it will be 20 omega cosine of 2 theta, okay? So V is equal to that. So that's option C. Okay, so you guys got that. On the second one here, you're looking for the acceleration. So then you'll be just doing time derivative to this equation. Okay, so on the left hand side, when you do time derivative, that gives you acceleration. So you do dv over dt, it gives you that. Now on this right hand side here, you are going to do time derivative to this thing here where 20 omega is a variable, and then cosine of 2 theta is also a variable. So you want to do break this into two. So this guy and then that guy, okay? So time derivative d over dt over this whole thing here. So then 20 comes in front here. Omega, if you do time derivative, becomes omega dot. Then write the second term down. Do not do anything to that because you are doing derivative the first term already. So then keep the second term unchanged, plus the first term unchanged times derivative to the second term, okay, cosine 2 theta. All right, so that's what you'll be doing. And then all this goes together with 20 in front. So then omega dot is alpha, 20 times alpha cosine of 2 theta. Okay, now you are doing derivative to cosine, it becomes minus sine. Okay, so this will be it becomes plus omega. Inside here is minus sine 2 theta. Then you'll be doing derivative, the pi chain rule here again, derivative to 2 theta. So 2 times theta dot. Okay, on this one here. Okay, and then again you would do parentheses over there. So in this, then you will have, now what you will be having is 20 alpha cosine 2 theta. Okay, the minus goes in front, minus 20, or actually 40 because there's a 2 here. So minus 40 omega, this is omega, there's another omega here. So omega square sine 2 theta. Okay, so this is what you have for the second one. So then it will be B, option B, okay, to be the correct answer on that one. Okay, so C and B. All right. So since you all got this right, I'm assuming you are clear on this one, but just in case if you have questions, just unmute yourself and then let me know, okay? So that's that one. All right. So let's go back to the PowerPoint. All right, now we'll take a look at one example here, I think. Then we'll be looking at attention quiz later. So this one, it says there's a link A and B. So A and B, it's been driven by this motor. It will rotate clockwise, so clockwise in that direction. Okay. Now at instant of theta equal to 60 degree, the slot, this guy here, guide rod is moving to the left. Okay, so 2 meters per second square as the acceleration, 5 meters per second as the velocity. It's asking you to find the angular velocity and angular acceleration of the link. Okay, so here the angle theta has already been defined. That's the reference line. All right, then you need to have another position variable defined. Okay, so in this case, it actually, the plane here, it gives is to set the coordinate x, okay, of to be a distance between A and B. Okay, so the x component over here to be the variable x. Okay, then you are going to relate x to the angular position theta. Then you can do time derivative, first time derivative and second time derivative. Okay, so you can relate the velocity of this point B with respect to the angular velocity. And then if you do second time derivative, you will relate the acceleration of this point B to the angular acceleration. Okay. Now, if you look at this slotted guide rod, okay, so this guy, okay, no, this guy over here. So if the whole thing is moving to the left at this instant, okay, now for this rod here, it will just have linear motion, right? Because it's not rotating, it just go either to the left or to the right. So this is going to be just a linear motion, all right? So then if the rod has this 5 meters per second as the velocity and 2 meters per second square as the acceleration, then point B over here should share the same velocity and acceleration, okay, so in the x direction, okay. So let's take a look here. So if we set up x to be the variable here, you can relate x to the angle theta. So then x from the geometry here, you can see x is going to be equal to this, the length of this AB link here, times the cosine theta. Okay, so AB length is 0.2 in meters, cosine theta. Okay. Now after that, you are going to take time derivative. So the first time derivative of the equation gives you x dot, okay, on the left hand side here. And then right hand side, you are doing cosine derivative of cosine becomes minus sine. You apply chain rule here again. You want to doing multiply by d theta dt, okay, that means theta dot, all right. So this is the first time derivative. Take a second time derivative, you get this one. So again, this one, you'll be applying chain rule again here. Or actually, it's the derivative of like A multiplied by B. So then you are doing derivative to A first times B plus derivative to B times A, okay? And then after that, you'll be doing chain rule to one of them, okay? Or if actually both of them, I think. So then this is what gives you, okay? for the first one, because sine becomes cosine, negative sign goes in front, and then you are doing theta, but you apply chain rule to the theta variable, so then it becomes theta dot square. Okay, so this is what it should have. Let me just show you here because it doesn't have the full picture. So x dot, let's get over here. X dot is equal to 0.2 minus sine theta, theta dot, okay? So then this is first time derivative. If you are doing second time derivative, that means you are doing time derivative to this whole thing minus sine theta and then theta dot, okay? So this is a variable, or this is varying quantity. This is another one. So you can think about this as A, this as B, okay? So if you are doing derivative to A times B, then what you are doing is you are doing derivative to A times B plus A times derivative B to B, okay? This is what you'll be doing. You apply it over here. So then it becomes 0.2 doing derivative of sine becomes cosine, so minus cosine theta, okay? But because theta is a variable with respect to time t, so then you want to apply chain rule here, you want to multiply by theta dot. So this is A, okay? When you are doing dA over dt, this is what it gives, okay? This comes from dA dt. Now let's B remaining, you just copy the B down, okay? Plus 0.2 with A unchanged, but you are doing time derivative to B, so that means theta dot becomes theta dot dot, okay? All right. So then this becomes, you take the negative sign in front, minus 0.2, okay, cosine theta multiplied by theta dot square, because there's theta dot here, there's another theta dot there, minus the negative sign goes in front, 0.2 sine theta multiplied by theta dot dot, okay? So there's a couple steps missing here, but this is what the second derivative of the equation gives you, okay? Second time derivative. All right, so then this is velocity, okay? This guy's velocity, this guy's acceleration, okay? And then this should be the angular velocity, or angular velocity. And this guy's angular acceleration, okay? All right, so I'm sorry, this is the velocity on the top here. And then this is the angular velocity, okay? Linear velocity, angular velocity, are relating them together, okay? All right. So then at this instance showing in the figure, theta is equal to 60, and it's given that velocity v or x dot is minus 5, because if you take positive to the right, then v is going to be negative, okay? And then x dot is going to be also negative, the acceleration, okay? Now this is assuming to the right to be the positive direction. All right, so then you can take these numbers into the two equations. You can figure out the angular velocity, okay? So take the numbers into the first equation, you get minus 5, which is x dot equals to 0.2 minus sine of the angle, and then this is omega, okay? Theta dot is the omega. So you solve for that one, it gives you 28.9, all right? Which in this figure, it shows that this is it's positive, okay? So that means this is going clockwise, because in this figure it shows clockwise to be positive direction, okay? So the clockwise. Now in the second equation, x dot dot is the acceleration, minus 2 equals to minus 0.2 cosine 60 theta dot square. You got theta dot from here, 28.9, okay, minus 0.2 sine 60 of theta dot dot. This is alpha. So you are looking for alpha, okay? So then by solving this equation, you get alpha, okay? Theta dot dot is equal to alpha, that is going to be minus 470, okay? the negative sign says this is going to be in the counterclockwise direction because clockwise direction here is assumed to be positive. Okay, so again, usual convention is we have counterclockwise as positive and then clockwise as negative. But you can see in this problem, actually you can do the other way around. Okay, so it could be arbitrary. Okay, so it doesn't really matter. All right. Any questions you guys might have on this one? Okay. If not, then we'll be looking at the attention quizzes here, two quizzes here. So again, let me set up the breakout room so you guys can work as groups. All right, and then after you are done, you can leave your breakout rooms, come back to the main section. Okay, so let's see breakout rooms. Okay, let's open it again.
Hi, Dr. Ho.
Hey, Dr. Ho.
Hi.
We
Hey,
found
Dr.
out the
Ho.
first one is 10 rads per second, but
Yeah.
So, hey,
it's going like
Okay.
this.
Good.
sweet.
That's right.
Yeah.
Yeah.
Yes.
So I just assigned Mariah to your room because the other room they're having 3, and then 2 other rooms they are already done. Okay, so I just assigned Mariah to your room. I hope
It's
that's
okay.
fine with you.
We will accept the burden of Mariah.
Yeah, she also left for some reason.
All right, she
Yeah,
just
she already left.
left.
Nice.
All right. All right. So
What are you gonna do?
let me see. So take a couple more minutes to look on 2, and then I'm gonna to ask you guys out in a couple of minutes. Okay.
Okay.
All right. See you later in the main room.
See ya.
See ya.
All right, so you guys are all back, and then I see most of you guys says A and D. Or for the responses I have so far, it's all A and D. So those are the correct answers. Okay, good job, guys. So anyway, let's take a quick look on the solutions here. So you have a link of A and B that can move freely in this slot here. So A and then B there. Okay, so it can move freely. So we are going to say we can take this point over here at the corner to be the origin, the fixed origin. So we can define the X to be the position of B, all right? And then for, or actually position of A, and then this is B there. I think we are given, let me see the PowerPoint slides. Let me share the PowerPoint slides with you guys. All right. So we are given that the velocity for A is known, so then we can take, all right, somehow my screen is not sharing. Let me do that again. Okay. All right, but basically, because A is given V as 10 at this instance, so we can take the position of A as the variable, then we can define the angle this to be theta. Okay, so as A goes in this direction, this guy is going down. Okay, so that's the direction of B we can determine. So then this angle is going rotating in that direction. Okay, in this direction, the counterclockwise direction. All right, so we are going to write the S in terms of theta. So this is 2 meters for the length of AB, A to B. So then it's going to be 2 times cosine of theta, okay? So this is the relationship between S and theta. And then for 1, we are going to do time derivative to this relationship. So you are doing time derivative to this guy, S dot equals 2 cosine, if you're doing the derivative, becomes negative of sine, so you can put negative sign in front, and then theta dot because you are applying chain rule here. Okay, so this then is omega. Okay, so this is V equals to minus 2 sine theta times omega. All right, in A, you're looking for omega here, and then for the instant when the theta is equal to 30. Okay, so then omega is equal to V over minus 2 sine theta that equals to 10 over minus 2 sine of 30. That would be minus 10, okay, radians per second. Okay, so minus, that means it's going in the negative direction because this is the positive direction, so the negative direction will be in the other way around, okay? So it's going to be 10 radians per second, and then in the counterclockwise, because clockwise is positive. Or actually, let me see. Did I miss something here? Or actually, oh, right. So, I'm sorry, I think we defined this to be positive, going that way, okay? So that's positive, so yeah, so we are right. So we are, it's going to be in that direction, okay? So because this guy is decreasing, okay? So in that direction, theta is decreasing, so positive is in that direction. I'm sorry, I messed up on that direction, but this gives you A, okay? So most of you guys got that right. on B, then quickly you are doing the second time derivative there. So that means you are taking this expression there, you are doing time derivative to that expression. Okay, V equals -2 sine theta omega. So then you are doing d over dt on this side and then d over dt on the other side. Okay, so this will be similar to what we did before for the concept quiz. You guys can refer to that one, but I'm going to just quickly jump to the final expression. So then alpha A, or oscillation A, is going to be equal to -2 cosine theta omega square minus 2 sine theta times alpha. Okay, this will be your final expression after a couple of steps of doing derivatives. All right, that's what you get. All right, and then you got this as 10 from this previous one, okay, or -10, but you are doing square, so it doesn't matter. And then 30 as the angle, and then 30 there, and then you get this one. It's given in this case, okay, as 10 also. So then you solve for alpha, okay. When you solve for alpha, it's going to be -183, okay. That's what you will get on that, okay. So that's that one. Sorry that I had to rush because we are running out of time, but you guys can do the derivative. You can refer to what we had earlier, okay? So let me know if you have questions. All right, otherwise, I wish you guys have a good weekend, okay? So again, be safe and healthy, okay? See you on Monday.
Bye, Dr. Ho.
Bye.
Yeah.